play. Because they are if there's a receptor on a cell for a product, a protein, it's receiving it because it needs that to make the cell do something.
So when it starts making those proteins, that's because it is, I guess, using energy to make its product, and so it needs more proteins in order to do that. Or like I'm like, I guess I don't understand how. I realize that when it hits the receptor and makes the protein, and then the protein makes more proteins, and then the cell makes insulin. But like, how does the protein act as a catalyst for that?
Now, okay, at this point, did you understand what I went through in the production of insulin?
Yeah, I mean the cell produces insulin because it gets the receptor and starts coding for the protein for the cell to make insulin.
Yes. Now, hold on to that thought for a second. Do we have to constantly have insulin produced? No. No. I do not have to have insulin constantly produced. How am I going to get the control over that? My autonomic nervous system. Okay, are you with me now, Brian?
Yeah, I mean, I get my...
All I want you to know at this point,
okay.
Understanding the production of insulin, meaning coded for by a protein, that's the genetic material on the chromosome. The way that I'm going to control that production for the insulin, I got to use my autonomic nervous system. Okay? So, my autonomic nervous system in the body, because I've got control centers, okay, they are monitoring levels of everything in my body. So, need more insulin, need less insulin, okay? They're going to release what's needed to control that. The only thing they can release is their product, which is that chemical that I drew in purple. Would every cell of my body need to receive information about the production of insulin? No. What cells in my body would need to receive that information? My pancreas cells that are going to produce it. Okay? So, they're monitoring it, and their response could be increase it, decrease it. Okay? So, there would be a receptor on those cells for the chemical from the autonomic nervous system. The way that it will affect the production, all right? In other words, the production of a pancreatic cell, which has its product being the insulin. Is everybody with me at this point? Okay? So, let's say that this reaches it. It could be excitatory or inhibitory. The way it's going to there's one of two ways that it can affect that cell's activity. We can either have a channel that allows that protein to cross and then begin to affect cellular activities, such as the production at the level of the chromosome, or it can attach, never cross the cell, but it makes this protein start up some activities which affect my G protein complex, which then can either affect my gene right on the chromosome or the product itself. Did that explain it, Brian? Tell me what I just told you.
So is the nervous system producing essentially signals for a light switch? One of the signals says start making what you're doing, and one signal says stop.
Yes.
It's like the feedback system. It's positive and negative feedback.
Yes.
Okay.
And the way it does it, it produces the product of the nerve system, which is the neurotransmitter. That neurotransmitter goes to a receptor on its target cell and affects how that target cell produces its product. Brian? Good? Does that help answer?
I mean, yes and no. It's just like what is the protein doing though? Like why does it need the protein? Why does it just like does the protein open specific chambers and like to usher the insulin out of the cell, or what is
no,
it,
it's
like,
actually
energy, or is it
it's actually affecting the gene located in the nucleus that would be producing the insulin. So it would be saying to that gene, make the product, don't make the product.
It's a command function. For
Yeah.
lack of a better term.
Like a better
It comes
term.
in and says, this is, you
This
need to
is
start
what you need
working or
to
stop
do.
working.
Right. And it does it all at the cellular level.
Now I'm assuming when one process is going, like you can't tell a cell to start working if it's already working. So I'm assuming when one process is going, that receptor goes away.
Actually, when you look at the cells of the body, based on where they're found, okay, are going to receive certain chemical messages, okay? And think about, for example, the reproductive system. The ones that would be receiving estrogen, testosterone, follicle stimulating, luteinizing, okay? Would we want, say, for example, cells of the intestines to receive those chemical messages?
No.
No. So receptors will be different based upon the cells where they're found.
So for the factor we're telling you to go ahead and
Make the product. It can have two different receptors for two different chemicals. One excitatory, one inhibitory. Working pretty much on feedback system. Okay, does everybody kind of understand it at that level where it's, because see, here's the key thing. It is either affecting the gene directly, the gene found on the chromosome and the nucleus of the cell. It's either affecting the gene directly or the protein that got made. Do you remember how the little mRNA leaves the nucleus, comes out to the endoplasmic reticulum, and the ribosomes attach, and you start putting together the amino acid chain? It can actually affect that amino acid chain. So, this system will have target cells, which are, if we look back at the pictures that we have had, the target cells are our viscera. We have learned that sympathetic needs to speed it up, parasympathetic needs to slow it down, and even though we're going to find certain neurotransmitters in relationship to the system, the fibers that are found on, I shouldn't say the fibers, the receptors on the cells will determine what action the neurotransmitter has. All right, is everybody with me at this point? So, when we look at the autonomic nervous system, even though more neurotransmitters exist, even in the general nervous system as a whole, we have major players, so to speak, okay? Think about, for example, with mood stability and stuff, dopamine, serotonin, that sort of thing. We have some big players in the autonomic nervous system. Mentioned muscarinic, nicotinic. And you guys were like, okay, well the nicotinic makes me think about nicotine. And we kind of mentioned the effect that has on the body. Thank you. The effect that has on the body. And then for the muscarinic, because it was named after mushrooms for some reason. Okay, go figure. Next. Huh? If we, y'all know shrooms. Okay, so ACH, the acetylcholine, look at what it's trying to tell us. At this point in time, we associate acetylcholine with being excitable, okay? It's telling me that this gets secreted, meaning it's released by the neurons, by all preganglionic neurons in both divisions. Let's stop right there and let's take it apart. If you look back at your pictures where you see the preganglionic fibers of our sympathetic division, thoracolumbar, parasympathetic, craniosacral, every single one of the pre-fibers releases acetylcholine. And by post-ganglionic for the parasympathetic. So in the craniosacral, both the pre and the post release my acetylcholine. Go back to your study guide, if you printed it out, you will see a question that's going to ask you about muscarinic, nicotinic. All right? Is that information that you could add to those answers for those two questions? Yes. Okay? So now, what we're going to say all right, the axons that secrete it, we term them cholinergic due to the choline, okay, from acetylcholine. And therefore, any receptor, which I tried to draw here, any receptor that binds it, meaning the little purple dot, let's say that's the acetylcholine, okay, if it can bind to the receptor, we call it the cholinergic receptor. Because acetylcholine is a big neurotransmitter in the autonomic nervous system. The receptors that we have on a cell